Hi everyone. We're going to continue working on test for review. This is the third part and we will start with question number 12. This question is asking us to write the first four terms of the sequence. The general form is given here. The general term of the sequence is given here. And we're going to find A1, A2, 3, and 4. To find A1, all I need to do is replace n with 1 in the general term. So A1 will be -1 to the power of n is replaced with 1. So this will be 1 plus 1. And then multiply by n plus 5. And n is 1 again. So it's going to be 1 plus 5. -1 to the power of 2 will be 1. 1 plus 5 is 6. So 1 times 6 is 6. So this is the first term. Next one, in order to find A2, this time we're going to replace n with 2. So this will be -1 to the power of 2 plus 1 times 2 plus 5. -1 to the power of 3 is -1. 2 plus 5 is 7. So the answer will be -7. To find A3, -1 to the power of 3 plus 1 times 3 plus 5. -1 to the power of 4 is +1. 3 plus 5 is 8. So the answer is 8. And you can do the A4 by yourself. Question number 13 is asking us to write the first four terms of this sequence. The first term is A1, and the general term is given as an equal to an minus 1 plus 1. So if I'm looking at the nth term, that's called an. An minus 1 is going to be the previous term. So when I look at this general term, it means that each term is equal to the previous term plus 1. So that's what this general term means basically. Now, A1 is already given, it's 9. In order to find A2, I'm going to follow the general term. It's the previous term, an minus 1, which is A1 plus 1. What is our previous term? A1 is equal to 9. So this is 9 plus 1 equal to 10. To find A3, you need to add the previous term by 1. So that will be 10 plus 1 because the previous term was A2 and that was equal to 10. So this is 11. Now, what is A4? That's the previous term, which is A3 plus 1. 11 plus 1, and that's equal to 12. So this is 12. The previous one was 11. Question 14, we need to find the indicated sum here. So I have sigma I equal to 1 to 6. I is the counter and starts from 1 and goes to 6. So first of all, I'm going to write the terms that I have here. As we already said, I is a counter and starts from 1 and goes to 6. So I could be 1, 2, 3, 4, 5, and 6. When I is equal to 1, the first term will be 4 times I. That means 4 times 1. Next one is 4 times I. That's 4 times 2. 4 times 3, 4 times 4, 4 times 5, and 4 times 6. And we're going to add them. All these needed to be added together. So this is 4 plus 8 plus 12 plus 16, 20, and 24. And when you add them all together, that's going to be equal to 84. So the answer is 84. You can also use your calculator to make sure you did everything right. So this is what I'm going to do with my calculator. I go math and go all the way down to summation. Enter. Now your counter, which is I, could be anything. It's just the name of a variable. So I'm going to choose X here. Starts from 1 and goes to 6. So I'm going to write from 1 to 6. And here I'm going to write the general term, which is 4 times I, and I'm going to write 4 times x here, and it's equal to 84. For question 15, we need to express the sum using the summation notation. So I'm going to look at the terms. It looks like every term has a constant part and a part that is changing each time. So the power is the one that is changing. It starts from 1 and then goes 2, 3, and so on. So I know this could be my counter, which starts from I equal to 1 and goes all the way to 11. And what is my general term? It looks like it's 3 to the power of I, and that's it. This is my sigma notation. Question 16, we want to write the first 6 terms of the sequence that A1 is given, and the common difference is negative 50. This is an arithmetic sequence. So if the first term is 170, the next one will be 170 plus negative 50, or I can just write minus 50, so that's 120. And the next one is going to be 120 minus 50. That's 70, and so on. You can just subtract 50 from each term to find the next one. Now, question number 17 is asking us to use the formula for the general term for this arithmetic sequence that A1 is 10 and D is 1. And then we need to find the 6th term of the sequence. So the general term for any arithmetic sequence looks like this. AN equal to A1 plus N minus 1 times D. This is the general form. Now for this specific sequence, A1 is 10 and D is 1. I'm not going to touch N at this point because this is my general term. For general term, we're going to keep the N. But then when I'm trying to find A6, the N will be replaced with 6. So this will be 10 plus 6 minus 1 times 1. So this is 5 times 1 is 5 plus 10 is 15. So 15 is the 6th term of this arithmetic sequence. Question 18, we're given a sequence here and we want to find the general term and also the 20th term. So first of all, we know this is an arithmetic sequence. It's already given to me. So I need to find A1, which is just the first term, and it's equal to 2. But also I need to find the D value. What is D value? To find D value, you're going to subtract the terms and write like 8 minus 2. So each term subtracted from the previous term, from the next term, that's going to be equal to 6. You can try for other terms as well, like 14 minus 8 is 6. 20 minus 14 is also 6. So that tells you that the common difference is 6. Now we're going to write the n-term formula or the general term, which should be an equal to a1 plus n minus 1 times d. As we know, for the general term, we're not going to touch the n. We're just going to replace a1 and the a1 is 2, n minus 1 times d, which is 6. Now we need to simplify because the question is asking us to simplify the answer. So this will be 2 plus, distribute the 6, 6n minus 6, and I'm going to write 6n, and 2 minus 6 is negative 4. So the general term will be 6n minus 4. Now we want to find a20. So all we need to do is replace the n with 20. So this will be 6 times 20 minus 4. 6 times 20 is 120 minus 4 will be 116. So the 20th term is 120. I'm sorry, 116. Question 19 is asking us to find the sum of the first 50 terms of this arithmetic sequence. So first of all, I know that in this arithmetic sequence, A1 is negative 18 and the d value will be negative 11 minus negative 18. That's negative 11 plus 18, and it's equal to 9. It's equal to, 7. So that's the d value and the a1. Now, if I want to find the sum of the first 50 terms, I need to use this formula. Sn, the sum of the n terms, equal to n times a1 plus an divided by 2. So first term plus the last term, which is the 50th term here, because I want to find S of 50. So I need to do 50 a1 plus a50 divided by 2. But what is my 50th term? So we're going to find the 50th term first, and then we're going to replace that here. Okay, to find a50, we need to do a1 plus 50 minus 1 times d, because that's the general term, a1 plus n minus 1 times d. So we replace n with 50. What is a1? That's negative 18. Plus 50 minus 1 times d, which is 7. When you calculate that, this will be equal to 325. Now we're going to replace everything here. 50, a1 was negative 18, plus a50, which is 325, divided by 2. And then when we use our calculator, this will be equal to 7675. So this is the sum, 7675. For question number 20, we need to find the sum of odd integers between 30 and 52. So let's list some of them. We don't have to write all of them. So the odd integers between 30 and 52 will be 31, 33, 35, and all the way until 51. So I know A1 is 31 and AN is 51, but what is the nth term? Like, what is the term number here? How do I find that? I'm going to use the general term, which is a1 plus n minus 1 times d. I know an, which is the last term here, is equal to 51. So I'm going to write 51 here, equal to a1, that's 31. I don't know what is the number of the term. That's what we are looking for. And the d value will be 2, because each term is added by 2 to go to the next term. So this is 2. Now I'm going to solve this for n. So 51 minus 31, this is 20, equal to, and I distribute the 2 here. That will be 2n minus 2. Now add 2 to both sides. This is 22 equal to 2n. And when you divide by 2, n is equal to 11. So I know that 51, the last term is the 11th term. Why did I even need this? I need to find the sum. And we know the formula for the sum is Sn equal to n times a1 plus an divided by 2. So I needed to know n, sum of how many terms I'm trying to find. So n is 11. 11 times a1, which was 31, plus an, that's 51, divided by 2. Now, when you calculate that, this will be equal to 451. So the answer is 451. Question 21, we want to find A3 for the third term of the geometric sequence, whose first term is this number, and the common ratio is also given as negative 1/3. So we're going to use the general term of a geometric sequence, which is an equal to a1 times r to the power of n minus 1. I'm looking for the third term, so A3. A1 is 8910, and the R value, which is the common ratio, is -1/3 to the power of 3 minus 1, which is 2. And when you use your calculator, this is going to be equal to 990. Question 22 is asking us to write the formula for the general term of the geometric sequence. And then we're going to use that to find A7. So I know A1 is 9. I need to find the common ratio for here. R will be, in order to find R, you're going to divide each term by the previous one, like 3 divided by 9. Which if you simplify, is going to be equal to 1/3. You can try for other ones as well. You can divide 1 by 3, which is just 1 divided by 3. And you can divide 1/3 by 1. That is also 1/3. So I know that R value is 1/3. Now I'm going to find my general term. The formula is AN equal to A1 times R to the power of N minus 1. And I know A1 is 9 and R is 1/3 to the power of N minus 1. And that's it. This is my general term. And now I'm going to find A7. Just replace N with 7. This will be 9 times 1/3 to the power of 7 minus 1, or 9 times 1/3 to the power of 6. And we're going to use our calculator. And it's going to be equal to 1/81. If your calculator is giving you a decimal value, then maybe it's even better if we find it on our own. So this is what is happening. 9 is 3 to the power of 2, and 1/3 to the power of 6 is 1/3 to the 6. So I can write 3 squared over 3 to the power of 6, which is going to be 1/3 to the power of 4, which is 1/81. So this is how you can calculate this on your own without a calculator. So question 23 is asking us to find the indicated sum, but it's asking us to use the formula for the sum of the first n terms of a geometric sequence. So you could find this sum using just expanding the summation notation, but since we want to use the formula, we're going to do it in another way. I'm going to, first of all, find the first and the last term, maybe first, second, and the last term. When I is equal to 1, I'm going to have 3 times 3 to the power of 1, which is 9. When I is equal to 2, the term will be 3 times 3 to the power of 2. That's 3 to the power of 3, which is 27. And all the way to I equal to 5. That will be 3 times 3 to the power of 5, which is 3 to the power of 6. However, I don't even need to know the exact value of that. We're not going to use that. The reason we're using the formula is that we need to learn how to do it. What if the sequence was from 1 to 50? Then it was really impossible to find all the 50 terms and then add them all together. So if we use the formula, it's going to be a shortcut and it's going to be easier to find the sum. So what is the formula for the sum of n terms of a geometric sequence? I'm going to write Sn is equal to A1 times 1 minus R to the power of n divided by 1 minus R. This is the formula for sum of n terms of a geometric sequence. So that's why I needed to find A1 and also I needed to find R. I know A1 is 9, but what is my R value? So I needed to find A2. Then I divide 27 by 9, which is equal to 3. So I know the R value is 3. So this will be 1 minus 3 to the power of n over 1 minus R. But however, I know that I'm trying to find the sum of the term from 1 to 5. That is 5 terms. So I'm going to write S of 5. And here instead of this N, I'm going to write 5. And if I use my calculator, that will be equal to 1089. For question 24, we're trying to find the sum of the first 12 terms of the geometric sequence. As you see here, if I want to expand the sequence and write all 12 terms, it's going to be harder. But if I use the formula, which was Sn equal to A1, 1 minus r to the power of n, you need to make sure you write the n on top of r. This is the r to the power of n, not the whole parenthesis to the power of n. So that's why I fixed that for you. So this is the formula, S of n, sum of the n terms. So we're trying to find sum of 12 terms. So this was S of 12. What is A1? It's given, it's 3. 1 minus, what is the R value? To find the R value, divide each term by the previous one. Negative 6 divided by 3 is negative 3. So the R value is negative 3 to the power of 12 divided by 1 minus negative 3. And I'm going to use my calculator to find this. So I'm going to make a fraction. On the top, I write 3 times 1 minus, in the parentheses, I write negative 3 to the power of 12. Close the parentheses and then raise to the power of 12. And then close the parentheses. And here I have 1 minus negative 3. And that's the answer. It looks like I made a mistake. I accidentally pressed the multiple. So I'm going to do it one more time for you. Sorry. So I have a fraction here, and I write 3 times 1 minus negative 3 to the power of 12. Close the parentheses, and in the bottom I have 1 minus negative 3. So this should be the answer. Negative 398,580. Question number 25 is asking us to find the sum of the infinite geometric sequence series. Notice that for the previous question, we didn't have infinite geometric series because we knew the number of the terms were, let's say, 12 here. So we have limited number of terms, but this time we have infinite number of terms. So it's a different story this time. First of all, we need to find the R value here. What is the R value? Divide each term by the previous one. So 6 over 7 divided by 6 will be, I can do keep pinch flip, 6 over 7 times 1 over 6. So keep the first one, change the division to multiple, and flip the next one. The 6 and 6 cancel, and 1 over 7 is my R value. And we know that if the R value in an infinite geometric series is less than 1, this is going to be a convergent series. Convergent series, that means it's getting closer to a specific number. But if the R value is greater than 1, then the series is going to have bigger and bigger numbers, and there's no end to that, and we are not able to find the sum. So if the R is greater than 1, there is no sum. If the R is less than 1, there will be a sum, and the formula for that will be Sn equal to A1 divided by 1 minus R. So this is, I mean, basically we don't have n. It's better if I don't write the n here because it's infinite number of the term. So notice if you have a limited number of terms and you want to find the sum, you're going to do Sn equal to A1, 1 minus r to the power of n over 1 minus r. But if you have infinite number of terms, you need to look at the r value. If it's greater than 1, there's no sum. If it's less than 1, you're going to use this formula. Okay, so here, the first term is 6, and the r value is 1 over 7. And now if I use my calculator, or I can just find it on my own, 6 over 1, I can write 7 over 7 minus 1 over 7. That's 6 over 7. And then change, flip. Keep the first one, change the division to multiple, and flip to 7 over 6. And they cancel, and it's equal to 7. So sum of infinite number of terms in this case will be equal to 7. Okay, so question number 26 is asking us to express the repeating decimal as a fraction in the lowest term. So first, I'm going to expand this. When we have this repeating number, it's basically 5 over 10, because it's 5/10, plus 5 over 100, plus 5 over 1,000, plus 5 over 10,000, and so on. So as you see, each term is multiplied by 1 over 10. So I see that I have a geometric sequence, and it's infinite geometric sequence. A1 is 5 over 10, and R is 1 over 10. Now I'm going to find the fraction, I'm going to use S, sum of infinite geometric sequence. That is A1 over 1 minus R. That's 5 over 10 over 1 minus 1 over 10. Now let's calculate this. 5 over 10. 1 is 10 over 10 minus 1 over 10. That's 5 over 10 over 9 over 10. And then keep, change, flip. So 5 over 10, keep that, change the division to multiple, and flip the bottom one. 10 over 9, these two cancel, and it's equal to 5 over 9. So that's the number. Now for the next one, this number, we want to find the fraction that created this repeating number. So I'm going to start with 71 over 100. And next time, it's 71 over 10,000, because each term is multiplied by 1 over 100. And next one will be 71 over 100,000, and so on. So we have a geometric sequence, it's infinite geometric sequence. A1 is 71 over 100, and R is 1 over 100. So I'm going to use the sum notation, or sum formula, which is A1 over 1 minus R. A1 is 71 over 100, 1 minus 1 over 100. This 1, I can write that as 100 over 100 minus 1 over 100. 71 over 100, 99 over 100. Keep, change, flip. 71 over 100 times 100 over 99. They cancel, and it's equal to 71 over 99. So this is the answer. So this was the third part of the review. I'm going to make another video for the last 4 questions because they need a lot of work. So I'm going to make a separate video for those.